I'm pumped about this one, my friends. Partial fraction decompositions. One of my favorite things to do in the world. We have done in a previous video some basic ones where you had nice linear factors on the bottom. But just to review the point there, we're taking in a rational expression and breaking it down into its parts, not by multiplication, but by addition. So what parts added together to create this? And that starts with factoring the denominator every time. We're going to have some different possibilities show up in this video for what happens when you factor that denominator. And let's factor this denominator first. First, we can take out an x and be left with x squared plus 2x plus 1. And then that quadratic that's left factors to x plus 1 squared, x plus 1 times x plus 1. Now here's what you do if you have repeated linear factors, right? I have x plus 1 and it shows up twice. What I need to do is put an a over the x. Okay, my first linear factor is x. I want to put a b over x plus 1, and that's normal. That's what we've done. My c, however, is not going to go over the other x plus 1. I already have a fraction with x plus 1 in the bottom. What I need to do this time is x plus 1 quantity squared. Okay, so if you have a repeated linear factor, put one letter, a, b, c, d, whatever you're on, put one letter over that factor, and then put another letter over that factor squared. The reason being, we do not know if the fractions that added together to produce our initial expression could have had an x plus 1, one of them, or it could have had an x plus 1 squared. You might have had one or both of those things, and it might turn out that b or c is 0, and that's fine, but we at least have to figure that out. Now think least common denominator. My least common denominator is x times x plus 1 squared. So a very common mistake is to multiply by things that you don't need. You don't have to multiply a, b, and c by everything that is not under them sometimes, and we'll see that in just a second. So what we do is set the numerator equal to a times x plus 1 squared, right? It has the x, but it needs two x plus 1 factors, all right? B is lacking an x, and it needs an x plus 1 factor as well. I should have specifically said this. The least common denominator is x times x plus 1 squared, because that's the denominator that I can make each of my fractions have through multiplying. The c only is lacking the x. All right, so just cx. Now remember, we've just essentially crossed out the denominator under all of these. We just kind of zoom through that step because there's no need to write it under them all and then cancel it out. Now we go to the easiest way to do these, if possible, is to choose convenient x values. All right. So what we're going to see in this video is sometimes there are no convenient x values, and that's when the real fun starts. But with convenient x values, if I let x be 0, I can wipe out this, which wipes out the entire term, and this, eliminating b and c and leaving me only to solve for a. Remember, when x is 0, it's 0 on both sides too. So I have 6 on the left because 5x squared plus 20x when x is 0 wipes out. On the right, I have a times 0 plus 1 squared. And then I've already said the b and c terms are wiped out because of the x term in there. So this is just 1 squared, which is 1 times a. So I've already got my first unknown. A is equal to 6. Now think about other good x values, other convenient x values that are going to wipe out stuff. How about -1? Okay, see if you can see why I chose -1. Okay, on the left, 5 times -1 squared is 5, minus 20 plus 6. So my left is going to be, what is that? -9. And the right is going to be, let's see, The A and the B wipe out, and I get -1 times C, or C times -1. So if -9 equals -C, C equals 9. So now I've got two of them. Okay, so now here's our first encounter with this little problem. We don't have any more good X values that are going to completely wipe out two of the letters. The good news is I already know two of my letters, A, B, and C. I know A and C. What you do in this situation is you let X be any number you want, 17, 22, 116, whatever. I would choose the next easiest X to work with. I'm going to choose X equals 1. It's not perfect because it's not going to wipe out letters, but I don't need to wipe out letters because I already know what two of them equal. So let's let X be 1 and see what happens. On the left, I get 5 plus 20 plus 6. So on the left, I get 31. On the right, I'm going to go through and let X be 1. So my first term is 1 plus 1, which is 2 squared. So I get 4A. Then I get 1 times 2, so that's 2B plus C, plus 2B plus C. Nothing wiped out, right? We choose these good X's because they're going to make letters disappear. And I didn't make anything disappear. That's all right, because I already know the values of A and C. This A and C apply no matter what X is. So I'm just going to take the two values. I get A is 6, so 4 times A is 24. B is the one I still need to know, so I'm just going to leave that as 2B. C is 9, so I get 31 equals 24 plus 2B plus 9. Subtract 24 and 9 from both sides, and let's see, 24 and 9 makes 33, so 31 minus 33 is -2 equals 2B. Therefore, B is equal to -1. Now, that's it. All right, B is -1, C is 9. Remember what we were doing in the first place, way back up here. Was trying to figure out how we break down 5x squared plus 20x plus 6 over x cubed plus 2x squared plus x. A is 6, so my final answer, 6 over x, plus B was -1. So you could do plus -1 over x plus 1, or you can just do -1 over x plus 1. And C was 9 over x plus 1 squared. And that is that for repeated linear roots. Okay, so the three fractions that went together, one of them had an x plus 1 in the denominator, one of them had x plus 1 squared, but we didn't know that until we got through the process. All right, as always, if you're not positive, add these three fractions together, which we did recently, and make sure you get back to the original. All right. Let's continue this excitement. Quadratic factors. Look at those factors in the bottom. Somebody was kind and went ahead and factored it for you. I'm going to treat the linear factors like I always did. I don't have any repeated linear factors. I have an x that shows up once and an x minus 1 that shows up once. And then I have this x squared plus 4. All right? That is not a repeated linear factor. That's a quadratic factor. It cannot be broken down into linear parts. If this were x squared minus 4, then I would break it down into x plus 2, x minus 2, but it's not. It's x squared plus 4. Quadratic factor. So here's the big difference between linear and quadratic factors. I do not just go C over x squared plus 4. The problem with quadratic factors is quadratic factors could have had linear expressions on top of them. So we need a linear expression, cx plus d. All right? These are linear. These are constant. Quadratic needs linear. All right? We need our degree to be 1 less. So think about straight line, y equals mx plus b. We're kind of writing that on top, but we're using a capital C and a capital D. From there, the process is pretty much kind of the same. We'll have one little difference here in a minute. All right, numerator multiply each one by what it's lacking. I'm going to pause and zoom to the future to keep this video a little short. Okay, so I've multiplied the numerators by the things they were lacking. In this case, the LCD is just x times x minus 1 times x squared plus 4. It's all of the denominators. And so each part needed the denominators of the other two parts. Now I'm at the stage where I choose good x's. Okay, my first good x, as it a lot of times is 0. Okay, I'm going to again pause and plug in 0 and zoom to the future. Be right back. And so now we have a equals 2. All right, pause this at any time and catch up with the notes. I don't want to I don't want to miss anything, but I also don't want this to last forever. Let's choose x equals 1. All right, when x equals 1, I get 2 minus 4 minus 8 on the left, which is 2 minus 12, which is negative 10. On the right, my a clump goes away. My b clump becomes b times 1 squared plus 5, with 1 squared plus 4, which is 5. And my c clump goes away. So I have negative 10 equals 5b, b equals negative 2. Okay, so now here's where something slightly different is going to happen. I don't have any more good x values, and I still have 2 letters left. I have a c and a d. Now, I can choose another convenient x, like negative 1 or 2 or whatever you want, and I can sub in and then plug in my 2 and my negative 2 for a and b, which is fine, but I'm still left with c and d, which makes this one a little bit more complex than our last example. Let's just plug in negative 1 and see what we get. All right. If x is negative 1, then I get negative 2 on the left, plus 4 minus 8, and on the right, x is negative 1. So I get a, which is 2, times negative 1 minus 1, which is negative 2, times negative 1 squared plus 4, which is 5. Okay, so there's my first clump. Nothing went away, but I knew what a was, so I went ahead and subbed in that 2 for that a. Okay, my next one is b, which is negative 2, times x, which is now negative 1, times x squared plus 4, which is 5, plus cx plus d. Now cx plus d, I don't know c or d, but I do know that x is negative 1, so it's c times negative 1, or negative c, plus d, times negative 1 times negative 2. Okay, so make sure that that line makes sense. I just went through, I subbed in negative 1 for x. I'm still left with c and d that I don't know what they are, but I'm just going to simplify this for now, and we'll deal with that in just a minute. So on the left, negative 2 plus 4 minus 8 would be negative 6. Let's see here, that's 2 times negative 2 times 5, that's going to be negative 20, and positive 10, and negative 1 times negative 2 is 2 times negative c plus d. All right, so let's see, negative 20 and 10, that's negative 10, so I'm going to add 10 to both sides and get 4 equals 2 times negative c plus d. And I'm going to divide both sides of that by 2 and get 2 equals negative c plus d. Now, I did not get c or d isolated, but I did get a simple equation involving c or d. So what's going to happen is I'm going to do that again and get a simple little system of 2 equations. Let's let x be 2 now, which is another fairly convenient number that I haven't used yet. All right, I'm going to have a little pause. Be right back. So here we are. I've plugged in x equals 2. I've plugged in the values of a and b that I knew, and I have another simple equation involving c and d. So here's how we finish this up. I'm going to take my first equation involving c and d, my second equation involving c and d, put them together, and have a nice simple little system of equations. All right, so you've solved system of equations before like this. You do substitution or linear combination, or there's a lot of different names for it. I'm going to multiply my top equation by -1 so that now I can add them. I get 6 on the bottom. I get 3c plus 0, which means my c must be 2. And then when I sub that back in, let's see, I get 8 equals 2 times 2 plus d, so that's 4 plus d, which means d must equal 4. And when I put all of that together, going way back up, c is 2, d is 4, my final answer is 2 over x minus 2 over x minus 1 plus, let's see, what was c and d? C and d were 2 and 4, so 2x plus 4 over x squared plus 4. And that was awesome. All right, so that's our first quadratic factor. It makes the finding of the a, b, c's, and d's a little more intense, but nothing that you cannot handle. So we're going to have to call that a day, and we're going to have to come back to repeated quadratic factors at another time. But for this video, repeated linear factors, you know what to do with that now, and you know what to do with factors that you can't break down into linear parts. They have to stay quadratic. Oh, that was fun. All right, so partial fraction decomps, the best thing you'll do this year. Young out.